Hello guys, in this video I'm going to show you how to solve median of a number string problem. So design a class to calculate the median of a number string. The class should have the following two methods: insert num and find medians. Insert num stores the number in the class. Find median returns median of all numbers inserted in the class. So the problem is given a number stream, right? So you try to imagine our inputs is not a fixed. It's not a fixed input, but it's coming as a stream, so that at any given point in time we want to find the median of that current stream of what has already come, what input has already come, right, in a most efficient way. So for example, so as you can see here is the insert is when data comes, right, when the data come. So stream insert 3 means inner stream 3 the first element, right? So the second element is 1. So now our input is, we have 1 and 3, but for now we don't care about the order. I just put it in order so that you can easy to recognize the median. So as you can see, the input now is 1 and 3, so it falls in the case that the amount of numbers now is even. So the median should be the average of 1 and 3, which is 2. Now one more number comes, which is 5. We have 3 numbers right now, 1, 3, 5. So the median is 3, right? The median is the middle number when you sort it, right? When you sort it in ascending order. So the output is 3. So next input comes, which is 4. Same here, we have 4 elements, so 2 middle elements. We need to find 2 middle elements, which is 3 and 4. We calculate the average, which is 3.5. So for this kind of problem, when we have a stream of data coming instantly, and we always want a way to extract median number out of the input, right? So that is something similar with heap problem, right? For heap, we always have access to the smallest element in case of min heap and the maximum element in case of max heap. But for this problem, what we want is a median, the middle number in the middle number, but not the maximum or minimum. So wanna use a technique called two heaps. It's kind of little bit hard to come up with. So I think you just need to get used to a couple of problems like this. Then the solution will come natural as you see it in the future. So the idea here is we're gonna use two heaps to store our input, right? So at any and the idea here is we want to keep our two heaps balanced. I mean the number of elements each heap is equal. For example, in this case, the total of 4 elements. There should be balance, which is 2 on one heap, two elements on each side, right? So probably that. So why we want a balance? Why we want balance here? Because when we have a max heap and a min heaps, and the two heaps are balanced, it means when we extract the maximum number of the max heap and the minimum numbers of the min heap, we will get the median number. For our problem, it can be in one. It can be either in min heap or max heaps, right? So for example, if our total elements is even and there's a 2 inch, for example, this guy, there's 4 elements in total. There are 2 in max heap and 2 in min heap. It means our median will be the average of the pick element in the max heap and the pick element in the min heap. But for the case of 3 elements, probably we want prioritize one heap should have one more elements than the other heaps. In this case, let's try to pick the min at the max heap. So the max heap will be heavier than the right heap. So at any given point in time, probably you want to maintain the max heap is equal or greater than at most one element, right? So it is going in this case, the numbers is equal or at max one element greater than the min heap. So I think let's code it out so you can, so it will be more clear. So constructor, this problem we need 2 heap, which is min heap. Here I'm going to use a third-party library, which is collections, and because JavaScript don't have heap implemented, so we need to pull it out from somewhere. So I'm going to declare the min heap, which is new heap. Initially it initialized with empty array. Equals, let it know, compare. This will determine if it is a min heap or max heap. Let's say max heap first. So if it's a minus b, it will be max heap. But let's check it. Let's check it from the console to make sure it is heap. So let's say we have 3, 2, 6, 4. For the heap, access the pick, it should be 6, right? So it's max heap. Any given point, and we always have access to the largest number at constant time. So for min heap, we initialize empty. Just need to reverse the order of A and B. Should be B minus A, so it's min heap. Okay. So we have 2 methods to implement insert num. This will see a test. Insert only, not insert. Insert. Take in a number, and we have 5 median also. The 5 median, alright. So probably we want to first we want to decide which heap, right? Which heap to push the number in. So after pushing, it can be imbalanced between the two heaps. So we want to rebalance two heaps so that we can have two heaps are equal in terms of number of elements. So decide which heap to push number in. So the way you want to push the number in is, so let's start with, in this guy, if for the first element it is when our heaps are empty, right? Let's say here's a max heap and here's a min heap, and as we insert 3, we need to decide which one to put in, because we need to prioritize one heap, and we decide the max heap. So for the case that left max heap is empty, right? For the case this dot max heap is empty, probably want to add the element, the number of the max heap, right? So after insert 3, it will be 3 here. So now it comes to the next element, which is 1. And for this guy, we probably want to how to decide which heap that the next number should come. So you can compare the current number with the either the smallest number of min heap or the largest number in the max heap, okay, to decide where to put it in. So we want to push the smaller numbers in the min heap and all the big ones in the max heap. So it means you want to compare the current one with either big of max heap, min heap, but there can be a case when min heaps is empty, which is in this case, right? So because here we have a check for for the max heap, right? So probably you want to, if the max heap, the peak, right? You want to compare it with the current number. Let's say the number is less than the largest in the max heap, so it should be pushed on the max heap, which is on the left side, right? So for this case, we insert 1. We're going to compare 1 with 3. We're going to compare 1 with 3. So 1 is less than 3, so it should be on the left side. So here is the case when the tree is in balance. Sorry, not the tree, but 2 heaps are in balance. So probably but before that, what if the num is greater than the largest number of the max heap on the left here? What if it's a 4 here, right? We probably want to push on the right side, which is in the middle, right? So else is that min heap add to num, right? So after here we want to rebalance the 2 heaps. So if the 2 heaps so how many cases we want to, it can be case if the 2 heaps number of 2 heaps, number of elements in 2 heaps is equal, probably don't want to do anything. But if any case here, if the max heap, which is on the left side, max heap on the left side, the length minus is not min heap, but length can be at max 1, right? But if it's greater than 1, we probably want to balance it by pushing the to the min heap. Sorry, the add, it should be at what? At the largest in the max heap pick. But for here it should be pop. You want pop out from the max heap and push into min heap. So it balances the tree. Is there any case that the max heap is greater than the min heap? Yes, there can be. For example, after insert 3, if the next is, let's say, 4, let's say example, let's say if it's 4, then it's 5. So we compare to 3 is greater, so it should be on the right side. Again, 5 compared with 3 greater, so it's come to the right side. So that can be the case when the mean heap is more than max heap. So probably if else if the mean heap or length is greater than max heap dot length, we probably want to take out in mean heap. What should be the function, and take out in the mean heap and add to the max heap. Right? So by doing so, we always have the two heaps are balanced. So the phi median is just simply extract out the pick of heaps. There are two cases. If the number in two heaps are equal, which is, you can check by length, mean heaps, the length are equal. This guy gonna return the average of two picks, which is average this dot max heap dot pick plus this dot mean heap pick, right? If it's not the case, can be because we decide to choose the max heap is prioritize max heap, so that can be the case when the max heap has one more element than mean heap maximum at maximum, because we have balancing check here. So if this is not the case, we come down here and return the pick of max heap. So let's run the test. Okay, so that's pretty much it for this video. See you in the next one.